Today I'll talk about Newton-Raphson method. Here is the problem statement. Find the root of the nonlinear equation fx is equal to x cube minus 2x minus 5 using the Newton-Raphson method. Use an initial guess of x0 is equal to 2 and perform 3 iterations. Now step 1, function identification. So function here is x cube minus 2x minus 5. And then for the Newton-Raphson method we need f dash x means derivative of the function, that is 3x square minus 2. Now here is the Newton-Raphson method. So xn plus 1 is equal to xn minus f of xn divided by f dash xn. And here is the convergence check. So stop the iteration when xn plus 1 minus xn less than tolerance limit after a specified number of the iteration. And here our task is to determine the approximate root after 3 iteration and analyze the convergence. Now so before doing the iteration, so here are the key equations. So Newton-Raphson method, we know that xn plus 1 is equal to xn minus f of xn minus divided by f dash xn. And here error estimation, though we are not doing, error mod of error is k into en minus 1 square. And stopping criteria, that mod of xn plus 1 minus xn less than the tolerance limit, that epsilon, or we can do that mod of xn plus 1 less than that epsilon tolerance limit. So here in this problem, so function is fx is equal to x cube minus 2x minus 5, derivative is f dash x is equal to 3x square minus 2, and iteration formula, that is if I put that in that Newton-Raphson method, so xn plus 1 is equal to xn, and this is the f of xn divided by f dash xn. So based on that we have to do the iteration. So now here we will do the iteration one by one. So now here is the first iteration. So n is equal to 0. So here initial guess x0 is 2. So first we have to calculate f of x0. So f of x0 is that f of 2, that is 2 cube minus 2 into 2 minus 5. So that will give minus 1. And f dash x0, so that is f dash of 2. So 3 into 2 square minus 2. So that will give 10. Now apply Newton-Raphson formula. So xn plus 1 is equal to xn minus f of xn by f dash xn. So here x1 is x0 minus f of x0 by f dash x0. So if I plug all this value, so that will give 2.1. And if I calculate that convergence x1 minus x0, so that will give 0.1. So as if I take that epsilon is something 1 into 10 to the power minus 6, something like that, so it is not matching, so we have to go next iteration. So next iteration is n is equal to 2. Okay, so here n is equal to 1. So now here that x1 we got 2.1, so this is 2.1, and based on that x1 we have to calculate fx1. So fx1 is here, if I after plugging everything, so 0.061, and f dash x1, so that is 11.23 after plugging x1 is equal to 2.1. Now apply Newton-Raphson method. So x2 is equal to x1 minus f of x1 divided by f dash x1. So after plugging all this, again x2 will be 2.0946. Now here if I calculate that mod of x2 minus x1, so that will give 0.0054. So now again it is not matching with this, so go to the next iteration. So now iteration 3. So now here that x2 we got, that is 2.0946. Now we take that x2 is this, and based on x2 we have to calculate next iteration. So f of x2 is, if I plug x2 is equal to 2.0946, we will get that 0.001857, and if I f dash x2, that will give, if I plug x2 is equal to 2.0946, 11.1619. Again apply Newton-Raphson formula, x3 we will get after plugging everything all this value, so 2.0946. so consecutive two values are nearly same, so x3 minus x2 will get something 0.00001. okay, so and if I calculate f of x3, so that will give 1.73 e to the power minus 9, that is nearly equal to 0. So since fx3 is very close to 0, so our approximate after 3 iteration is very good. So the actual root is approximately x is equal to, this is something 2.0946. so that actual root is approximately 2.0946. so this is the root. Now if I summarize the result, so in that here in the table, So in that table, when n is equal to 0, so the approximation is 2.0, means x0 is equal to this, x0 is equal to 2.0, and based on that function value is -1, derivative of this 10, and error is first iteration, no error, and then n is equal to 1, so approximate value after Newton-Raphson method will get 2.1, and then function value is 0.0610, and derivative this, and error is 1.1000, and then again Newton-Raphson formula here will get this value, and based on this we'll get that function value is something like 0.001857, derivative is 111619, and error is 0.0054, and then again Newton-Raphson formula will get the root is 2.09646, so that function value is nearly equal to 0, and then derivative is 11.1728, and error is something 0.00. Now here this function value is nearly equal to 0, so when some f of x is equal to 0, so that x will be the root. So now here the root is this, root is 2.0946, that is the root. That's it. Thank you.